If you've ever sat in front of a Commodore 64, you know this screen. That iconic ready prompt with the blinking cursor. It's like a blank canvas, just waiting, just inviting you to create something. Well, today, that's exactly what we're going to do. We're going to turn this empty screen into a full-blown space shooter using nothing but Simon's Basic. So let's get to it.
You know, building a game on 8-bit hardware like this, where you have very limited memory and processing power, it's all a delicate balancing act. It really comes down to 3 core pillars. First, you've got vision. That's the graphics, the sprites, everything that brings our world to life. Then there's audio, those unforgettable sounds coming from the legendary SID chip, which is basically a synthesizer built right into the machine. And finally, the most important part, action. That's the code that ties it all together, from reading your joystick to figuring out when you've hit something. For a game to feel right, these 3 things have to dance together in perfect harmony. So let's break them down one by one.
All right, first up, vision. Before we can have a spaceship battle, we need to build a universe for it to happen in. This is where we take that blinking cursor and start painting our digital battlefield.
We're going to start with the background, the stage for all the action. And in Simon's Basic, this is actually pretty easy. We can use a block command to draw the planet's surface, then a line for that altitude marker. And for those weird alien plants, that's just a circle command combined with paint. It's really like painting on a canvas, where each command is another brushstroke, building up the world where our game is going to live.
Okay, now let's talk about a really crucial choice you have to make. The C64 has 2 main graphic modes. There's high-res, which gives us super sharp, detailed lines. Perfect for the background we just made. But here's the catch. You only get 2 colors inside any little 8x8 pixel square. For our spaceships, though, we want more color, more personality. And that's where multicolor mode comes in. It's a clever little trick, really. We give up a bit of horizontal resolution, things look a little chunkier, but in exchange, we get to use 4 colors per block. It's the secret sauce that makes our sprites really pop.
So what exactly is a sprite anyway? Well, under the hood, it's really just a bunch of data. The first thing you have to do, as you can see at the bottom of the stack, is tell the computer where to store that data. Back in the day, we had to manage memory ourselves, so we're setting aside a specific block right at memory location 15176. Once that space is reserved, we can define the sprite's properties, what colors it uses, things like that. And then finally, the top layer, we tell the computer exactly where to draw it on the screen with some simple X and Y coordinates.
And this is where the magic really happens. This shows you exactly how that raw data becomes a picture. We use the design command, and the code you see on the left becomes a literal blueprint. See the letters B, C, and D? Each one maps directly to a color from our palette. And the periods? Those are just transparent pixels. The computer reads this block of text and translates it symbol by symbol into that awesome little spaceship on the right. It's such a direct, visual way to make art with code.
So our world is visible, but it's completely silent. Let's fix that. It's time to tackle our second pillar, audio. We're about to fire up the C64's legendary SID sound chip and give this game a voice.
Making sound in Simon's Basic is like a little assembly line. It's a super logical 5-step process. First, you use VOL to set the master volume. Then, Wave lets you pick the basic texture of the sound. After that, Envelope is where you sculpt it over time. With music, you write out the actual notes. And finally, Play just flips the switch and makes it all happen.
Now, that wave command is really clever. It works using a series of 8 on or off switches. And as you can see here, each switch controls a totally different sound character. We can flip one switch on to get a smooth, flute-like triangle wave, great for a melody. Or flip another one to get a sharp, brassy sawtooth wave. And for our game's lasers and explosions, we're going to flip the switch for pure white noise.
You know, a raw sound wave by itself is pretty boring. It's just a constant, flat beep. The envelope command is what turns that boring beep into something that sounds real. Think of it like shaping clay. Attack is how fast the sound gets to its loudest point. Decay is how it drops off a bit after that. Sustain is the level it holds at, and release is how it fades away to nothing. By just tweaking these 4 numbers, we can make a sharp laser blast or a long, swelling musical note.
So here's a little cheat sheet of those commands. You can see how each one uses really simple numbers to control the sound. But I want you to look closely at that play command. Using a 2 there is a total game changer, literally. It tells the computer, hey, play this music in the background, which frees up the processor to handle all our game logic at the same time. It's absolutely crucial.
Okay, we've got our graphics, we have our sounds queued up. Now for the final, most important pillar, action. This is where we stitch everything together into a living, breathing experience, all driven by the heart of every video game, the game loop.
This right here is the beating heart of our game. The game loop is just a relentless cycle that repeats itself dozens of times every second. It starts with initialization, setting the score to 0 and all that. Then it draws our world. But the real action is in the core loop. It reads your keyboard, it moves the enemy ship, and most importantly, it checks for collisions. And if the game's not over, it instantly jumps right back to the beginning and does it all again. That constant high-speed cycle is what creates the illusion of smooth, interactive gameplay.
So how do we actually control the two ships? Well, for you, the player, it's super direct. The code uses a command called peek to literally peek into a specific spot in memory, address 197, which tells it what key you're pressing. But for the computer's AI ship, we want it to be a little unpredictable. So it uses a random number generator, RND, to decide where to go next. We've given it a little bit of a bias so it drifts menacingly across the screen, making it a much tougher opponent.
And here it is, the moment where everything comes together. A single line of code, if check, uses the hardware itself to instantly detect a collision. The very moment that happens, it kicks off a chain reaction. Visually, your score goes up on the screen, and at the exact same time, the audio pipeline fires up to make that awesome explosion sound. This one line of code is the perfect synchronization of our three pillars: vision, audio, and action, all working together in perfect harmony. And just like that, we've built a complete game from scratch. But listen, this isn't the end. Far from it. For you, this is where the real fun starts. This is where your adventure truly begins. Now that you understand the architecture, you know how the graphics, the sound, and the logic all talk to each other, you have all the power. You can change anything you want. So let me ask you, how would you make this game more challenging? Need some ideas? Here are 3 to get you started. Want a faster, more aggressive enemy? Just find line 1180 and bump that movement value up from 7 to, say, 10. Or maybe the game's too easy for you. Go to lines 1270 and 1280 and slow your own ship down. Or what about making the enemy lasers deadlier? In line 1240, just change that last number. And here's a tip, a lower number actually makes the projectile faster. Don't be afraid to get in there and mess around. Just type list, find these lines, and see what you can create. Working on a machine like the Commodore 64 teaches you something profound. These commands, they aren't just code, they're creative solutions to very real physical limits, and it really proves a golden rule of engineering. Having strict limitations doesn't stop creativity, it forces you to be even more creative. We've shown you the tools. Now it's your turn. Go back to that ready.prompt and go build something amazing.